Section 1.6 is classifying polygons, so giving them a name. So first, what is a polygon? A polygon is a closed plane figure, so that means it's all in one plane and not disjointed. It's formed by 3 or more line segments called sides. So 3 is the least amount because you need at least 3 sides to close it in. Each side intersects at exactly 2 sides at one endpoint. So you can't have an endpoint and have 3 sides coming in on it. Okay, you can only have 2 things coming into the point. And then each endpoint of a side again is called the vertex. So we have convex polygons, which means like all of the sides are sticking out. There's no weird juts inside. We have concave polygons, which I like to think about as being caved in. So if I was to draw, okay, you can see that that part's caved in. Another way to think about convex is if I was to connect any vertex, it doesn't stick outside, my dotted lines don't stick outside the polygon. Where like on this one, if I was to connect these 2 vertices, okay, it's outside my polygon, part of my polygon is inside that dotted line. Okay, so tell whether the figure is a polygon, and if it is a polygon, whether it's convex or concave. So part A, actually let's go back for a second. Again, this is formed by 3 or more line segments. So segments are straight lines, okay, and only 2 sides can intersect in an endpoint. Those are key things to look for. So part A, is this a polygon? Well, we have 3 parts that intersect here and over here on this side as well. So this is not a polygon. If those were split up, and so we only had half of one, then this like trapezoid piece would be a polygon. But because there's that line across the middle, that makes it not a polygon. B, is this a polygon? Yes. Okay, there's no weird curves or lines connecting in the middle. And then is it convex or concave? Well, I don't see any parts caved in, and if I was to draw my lines connecting my vertices, they all stay inside. So this would be convex, since there's no cave in. Now, this one, is this a polygon? And you might say, yeah, it's a triangle, but if you notice, this part here is actually curved. And our polygons are formed by segments, which are straight. So this is not a polygon. Okay, and the last one, is this a polygon? There's no connecting in the middle, there's no curve, so yes, it's closed in. However, is this convex or concave? So if I was to draw those 2 vertices together, part of it is inside, this part's caved in, and that's true on all 4 sides. So this is concave. So to classify polygons, polygons are named by the number of sides. So some have special names and some don't, because after a while we get too many. So if it doesn't have a special name, it's an n-gon, and n is just the number of sides. So like 100-gon, for example, if it had 100 sides. Okay. If it has a special name, then we'll like to use that instead. So just a couple things. Equilateral means that all sides are equal. So I'm just going to draw a triangle, for example. If all sides are the same, okay, that's equilateral. Equiangular is all angles are the same. So for example, let's just draw this. This is a rectangle. This would be equiangular because all of the angles are 90 degrees. And then regular is if it's both equilateral and equiangular. So all the sides and all of the angles, like a square. All these sides are equal and all the angles are 90 degrees. So that would be a regular polygon. So there are some special names for 3 sides. We know that's a triangle. 4 sides. You might think rectangle or square or something, but all of those have 4 sides. Same with parallelogram and a trapezoid and all those. So 4 sides, those are all types of quadrilaterals. Okay. 5, think about what's in Washington, D.C. So that would be the Pentagon. 6 is a hexagon. Most of you know that one. 7 is similar. It's a heptagon. So hexagon and heptagon. 8, stop sign, is an octagon. 9 is a nonagon. 10 is a decagon. And 12 is a dodecagon. So 11 doesn't have a special name, that's why it's not on there. So if it doesn't have a special name like 11, you call it an 11-gon, or 13 a 13-gon, or 44 a 44-gon. So in general, whatever n is, it'll be that and gon after it. So 99-gon or 101-gon. Okay, so I do expect you to know the names, so make sure you read through those. So this says classify polygons by the number of sides, and then say, is it equilateral, is it equiangular, is it regular, or it could be none of the above, if there's nothing special about it. So this first one, I count how many sides. 1, 2, 3, 4, 5, 6 sides. So 6 sides is a hexagon. I notice that all 6 sides are equal. I also notice that all 6 interior angles are equal. So that would make it regular, because all the sides are equal and all the angles are equal. So that makes it regular. Part B, I see it has 4 sides, so that would be a quadrilateral. Okay, I see that there's one set of sides and another set that are equal, but not all 4, and same with the angles, so it's none of those. It's not equilateral because there's only two sets of sides, and equiangular, same. So if it's not either of those, it can't be regular. Now the last one is a little bit tricky. Okay, so let's count my sides first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So dodecagon. Now, when we're talking about equilateral, that's good. All 12 of those sides had marks. So this is equilateral. When we're talking about equiangular, when we're talking about angles, we're talking about interior angles. So I see a right angle here. However, when I come to this part, the right angle's on the outside. So this inside part is not a 90-degree angle. It's actually 270 degrees. So this angle inside and this angle inside are not equal. So it's not equiangular, which means it can't be regular. So it's just equilateral. And in general, if it's concave, so this has the cave in, it's never going to be regular. Okay, it might look like it is, but keep in mind that this right angle is outside, so it's not equiangular. Alright, last thing, the table is a regular hexagon, so we have to keep in mind what that means. What does regular mean? Regular means all the angles are equal, which doesn't do us a lot of good because we don't know anything about all the angles. But it also means all the sides are equal. So, if the sides are equal, we might as well set them equal to each other so that we can find x. So I'm going to subtract the 3x over the 6 equals x minus 2. Add 2 and 8 equals x. Now it didn't say find x, it said find the length of a side. So we know all the sides are equal, so it doesn't matter which one you pick. I'm going to pick this one. So 3x is 8 plus 6. 3 times 8 is 24, plus 6 is 30 inches. Okay, if you would have picked the other one, that would have worked too. You would have got 4 times 8 is 30. minus 2, or sorry, 4 times 8 is 32, minus 2 is also 30 inches. So again, it doesn't matter which one you pick. We know all the sides are equal, so we're good there.